Good morning, good afternoon, good evening, everyone, and thank you for joining this webinar on digital twin strategy, looking at our strategy to execution pyramid. Thank you for joining, and let's jump straight in. So I'm Peter van Schalkwyk. I'm the CEO at XMPro, and my background in digital twin started about 6 or 7 years ago, leading the digital twin interoperability task group inside the Internet Consortium. And for the last 2 years, I have also been involved with the Digital Twin Consortium, where I lead the Natural Resources Working Group. And with Shyam from Deloitte, previously with GE, I also co-wrote a book on building industrial digital twins, how to design, develop, deploy, and create these digital twin solutions for real world industry. So I have some background in this, and thought I'd share some of the learns that we've had over the last couple of years in terms of how to connect all of this and create a coherent strategy for digital twins in the organization. Before we start with the strategy side, I thought I'd take just a few minutes and make sure that we sort of have the same understanding around what we mean around some of the digital twin concepts and definitions. We often find a lot of confusion around what digital twins are. This is my view, so and that will be the context of the presentation as well. So, using the Digital Twin Consortium's definition, it's a virtual representation of real-world entities, which could mean a number of things. And a key aspect is that it is synchronized at a specified frequency and fidelity. And it's underpinned by three key enablers from a digital twin perspective. The first is that it is there to support decision making and understanding and driving effective actions. The second one is that it is kind of built on real-time data as well as historical data, and the idea is that it can represent the past, what's happening right now, and also simulate predicted futures. And it is all driven and motivated by outcomes, which links to our strategy discussion of today. It is focused on use cases, and again, I'll talk around how that fits into the strategy side of things. And obviously, this all needs data that sits behind it, and you need to know what this thing needs to do. So it requires domain knowledge. So those are the three pillars that underpin the definition from a digital twin perspective. To put that into a picture, we have the physical environment over here, the entity of sorts. It could be any type, and on this side we have the virtual representation, and there's data that is synchronized, and sometimes some of the information can go back. And we have the twinning rate, which is that synchronization, and there's this physical to virtual connection, which could go bidirectional or both ways. One of the key concepts of a digital twin is that it's a model-driven architecture. If you kind of go back to from a software design pattern, it's actually that it's built, that digital twins are built to a model or a prototype. Well, what Dr. Greaves initially termed a digital twin prototype. So the prototype is the template. We sometimes talk around templates, but there's a certain template for a certain class of asset. So, for example, we have a template for these pumps, and then each of the individual pumps are then instantiated. So there's each of these use the same model. So those are referred to as the instances or digital twin instances. And if you combine some of these things in different ways, shapes, or form, either a number of these together or different ones of these, but into a single thing, a single higher level twin, these are referred to as the digital twin aggregates, or quite often as composites as well. How this all fits together from when is it or when does it get instantiated? When does it become a twin? If you look at a product life cycle, again, let's take that pump or a motor or any entity, and this could be a supply chain or something like that as well, which falls under more the process type of digital twins. But if we look at that pump or motor, when we just have a model, we still don't have a twin. We have got a digital twin template or digital twin prototype, but it's not necessarily a digital twin. When the decision is made to make that, so I can get a serial number or allocate some unique identifier to it, and then start populating the model with some real-time information around the either design, manufacturing, or whatever it is. That's when the twin is instantiated, and now I'm starting to create a physical device. As you can see now, we have an instance and we have the type. And as we start putting this together in a larger either system or system of systems even, we get to, and we start putting system context to it. We start building out and start building these aggregate or composite digital twins. And then when we put them into operation, we get real-time telemetry and other data to it. This is when we actually add another dimension from a digital twin perspective. If we look at the factory, however, the life cycle could look slightly different, and the facility that we create to do this. So in that, we may plan, design, build, commission, operate, maintain, and improve the facility. There are use cases across all of this, but those tend to be quite often project driven, and this is continuous. And this is where different types of twins fit in as well, what we refer to as simulation twins and operational twins. And I'll touch a little bit on the difference on some of those as well. But that's more from a factory perspective, how this would fit in. Another question that we quite often get is what's the difference between a digital thread and a digital twin? And if we look at those life cycle phases, depending on how you represent them, digital twin use cases typically span across, they address a specific problem. You're hiring the twin to do a specific thing in that life cycle. And the digital thread is that digital breadcrumb that builds up data across all the different life cycles. So I can then track throughout the life cycle all the interactions that the product or environment facility had with different use cases and how that is built up. So again, just very high level. If anyone's interested, we can delve into this in a later webinar, going more into some of these concepts, but that was just at a high level. The one last question that I often get is, so is a simulation model a digital twin? Because we've spent a lot of money on building these simulation models using computational fluid dynamics, all of this, and how does this, is this a digital twin? If we go back to the definition, if it's not synchronized at a certain frequency and fidelity, it is a digital twin prototype potentially. It is a model. If it is synchronized, then it can become a digital twin instance. I can use the same simulation model I can either connect it up or not, and that would be the difference. So using or creating these digital twin prototypes, they are critical in design, but some of them may be thrown away, or a lot of them might be thrown away and actually not used in the digital or the instantiation of digital twins. When I take that same simulation model and I wire it up with and synchronize it at a certain frequency and fidelity, that's when it becomes a simulation twin versus a simulation model. So that's just at a very high level some of the concepts that we refer to quite often when we talk about digital twins. But let's change gears and talk around the strategy side of things. So we refer to this as the digital twin strategy to execution pyramid. And again, we like to use frameworks for this. Now, what we've seen over the last couple of years working with a number of customers on this in various industries and at various sizes of enterprises, if it's done right, it is an accelerator for digital transformation, which is kind of the holy grail that a lot of organizations are trying to achieve with this. The important part is that the value levers should be connected almost as golden threads from the top to the bottom of the organization, and that's what drives real change. So what we seeing is that digital twins done right actually focus on pulling the right value levers to get quick time to return on investment, and that'll drive more adoption. Making sure it is connected, that golden thread, is a key aspect of being able to achieve that. And if you want to do this at scale, and you want to do this in a short period of time, it does require a kind of a composable or reuse of package capabilities. And this is the topic of another webinar. But for today, we'll focus on how to create that digital twin strategy that spans across the different levels of your organization. So at a strategic level, the digital twin provides a macro view on business metrics. It focuses, it differs from kind of loose standing dashboard KPIs that we quite often see, because it's a more integrated view that you can only achieve if you look at it from a model-driven approach, if you look at your business from a model-driven approach. And quite often that model is the value chain across the business. So it ideally models the business from a macro view. And again, it differs from just loose standing dashboards that managers use, in the sense that there's a thread which I'll go into in a bit more detail. At a tactical level, the digital twins support planning functions. So, and it is really focused on removing constraints, because it's one of the challenges that we have in organizations. We have limited resources in different ways, shapes, or forms. And what we need to do is make sure that in order to get our strategic view executed, that we actually manage the constraints that sit in the middle. And that's quite often a planning view. And then lastly, we have the task view, which is at an operational level. We focus on how to get things done, but again, how it's connected. Now, quite often the time frames or the application for this differ. So when we put a lens on, we look at a strategic level, quite often it starts off with annual, quarterly, or those kind of reportings, even down to weekly. And there are some metrics which may be at a strategic level important to understand on a daily basis. Likewise with tactical, because it's so focused on constraints, it looks at almost all 4 levels of time frames. So that it can provide a holistic view from a planning perspective. And at the task level, quite often it is predominantly focused on what's happening right now. So by the hour, with a view on daily, and quite often I need to also understand how this fits, or what's happening from a weekly time frame, and how my actions impact that. So that provides just a kind of a high level view in terms of the different requirements for this. So looking at it from a what do you? We often refer to digital twins are hired to support different users at different levels, and we typically see that those strategic digital twins service executives and senior management. Likewise with tactical, it's supervisors, engineers, planners, those type of roles, especially in asset intensive industries. And then operators and technicians, people who are really focused on how do we make those things happen right now at that operational level. But I forgot to mention on the previous slide, it is focused on quite often in asset intensive industries, there's four main mega use case buckets. The first one is around business performance, which tend to be more strategic and tactical. The process optimization is again, it could be the physical process like you have in a mine, or it could be the business process optimization side. ESG monitoring compliance, we see so much more of that emerging, where digital twins have a significant role in making sure that we are compliant in terms of a number of the initiatives going on. And where this all started for a lot of organizations was around asset performance use cases. So these are the kind of 4 main buckets that we see where value levers are identified from a digital twin perspective. The interesting thing with this pyramid, it almost mimics how we synthesize and get data. So at operational level, we have a lot of data and a lot of data collection. And as we go up, we start turning that data into information right to the top. So we're seeing that the strategic side of the business requires quite often less integration points. But what we see is that the impact of the decisions made at that level, it quite often has a bigger impact on those levers and the overall business impact. And as it goes down, the impact of the decisions gets smaller. Doesn't mean that the decisions are less important. It is just in terms of how it impacts the overall outcome when you drive towards certain outcomes. It's interesting. I recently saw this from on a Gartner report, and it's interesting to see how they anticipate digital twins grow. So what you see, the light blue is 2021. This is all where we are right now. Discrete or single type IoT based digital twins seem to be predominant. And as a digital twin of an organization is more that business process level, the business level view, and then the composite is the ones that we start putting together. It's really interesting to see how they anticipate that grow, and if we align that with the different use case types. I think at the moment we're seeing a lot more of these single, let me build something around a specific asset. But as this goes forward, there's a lot more awareness, and the value will be realized on digital twins as we start building out to more higher levels and help drive better decisions from a strategic point of view. So I thought that was just interesting how that aligned with what we're seeing. In terms of our experience and working with customers in different specifically asset intensive industries, it's interesting to see how the ones who do it well, how that is approached. And here's an example looking at from a mining perspective. So the strategic levers here that drives the digital twins. A lot of mining organizations are now in a position, due to the global challenges and supply chain problems and things like that, where they can literally sell as much as they can dig out the ground. So the value levers are that obviously safety and ESG are key focus areas for all of those industries. But inside that, right now, a lot of organizations they can sell as much as they can dig out the ground. So they need to run more often as a key value driver. When you're running, you need to produce more tons. When you're recovering those tons that you've dug out the ground in the chemical processes, you need to recover more. And in all of this, how do we focus also on making sure that we're not blowing out our costs as we do this? And that is the strategic view that the senior executives want to have, and that's the role that they want to hire a digital twin to give them decision support on how we're doing around this. That's then broken down into different initiatives. So, for each of those, you can identify a number of different initiatives. So in order to run more, we need to reduce the shutdown, the duration that our shutdowns take, and also can we get away with less bi-weekly, or can we extend the periods or things like that. Same with running more product. Creating more products. So how do we make sure that the conveyors are more operational? How do we, from a recovery point of view, looking at our chemical processes, how can we optimize that? Lowering costs. If we bring in digital twins to help us with that, we should always look at how does the thread for each of those go from the top to the bottom. So how do we connect that runoff and strategic to the tactical application and then the operational side of it? So that is really what I would call the magic sauce, how this how you get from the top to the bottom, that it is always focused on driving the key value levers. Otherwise, you are building digital twins that won't drive ROI. And make sure that to ask the question, what are the decision support or decision automation requirements at each level of the triangle for each of these initiatives, to make sure that we establish this golden thread between the strategic and the tactical side of it. Sometimes, and we've seen organizations just start with, at the operational level, I want to build this one thing. If you don't ask the question, how does it support a tactical view in the organization? How does it support the strategy? Those things don't tend to go anywhere. But practically, how do you do this? How do you connect? So when you link this golden thread through all of this, what we find very useful is if you use diagrams like this in that, where you really start with, for a specific use case, that specific initiative that we identified. So right at the top, it is run more often, and the specific objective that we're going to try and do is reduce the shutdown times on our plant. Those metrics then go in the top, and for each of these, you draw them down and describe what it would look like, what the twin would be, or what the operational requirement would be from a key metric perspective. What are the key metrics we're going to deliver? So if we understand what the metric is, we can then look at what analytic can provide it, and then we can look at what data do we need to drive that analytic. So again, if each of these, we know what the outcome is that we want to achieve, what is the thing we're going to measure at each level for that initiative. If we know that that key metric, we can then understand what analytic will give that to us. What do we have to do to calculate or work it out? And then we will know what data to do. So don't start with, I've got all this data, what can I do with it? Which is one of the biggest bugbears that I have with how people often look at digital twins. So this framework is very simple, but very, very effective to put on a screen and work with the team to make sure, now, what does it look like when you put some of this into action? So again, those metrics at each level, so whether you're going from the overall site to a plant level, right down to equipment level, how does it break down and how does it fit together to provide that golden thread view going through. The best way to describe this is just to also show you a few examples of this. So if we look at that strategic event board, and here's an example of a value chain. The data and values have been anonymized so that we don't show any customers' real data, but this is a whole value chain for a senior executive team and the senior executive's objective of this is, I have a lot to do when I get into the office today. Let me have a look at this and understand where I need to apply my energy. Now, how does this differ from a normal dashboard that you would have? Well, there's real-time monitoring on these KPIs, and as soon as one of those KPIs fall out of a certain range or business rule that you've defined, which in this instance we present as an executive recommendation, then it would immediately notify them. And it could be an ESG event, there could be a breach there could be a safety event or anything like that. But from an operational perspective, based on those drivers that we've defined, when one of those things go out of spec, I need to know that I need to do something right now. And again, this is a holistic picture. This is a business. This is a model of my overall business. It mimics my business model as well, in terms of how we want to sell and what we want to drive. So, key difference seems very simple, but I can see key metrics updated in real time. But also, we can make sure that we have consistent responses and that we respond to certain events that happen, so that when one mine has a problem or that the other one, or if two minds have the same problem, that we don't have two different responses in terms of the senior executive, how that is done. We can set up these executive recommendations, review them, and make sure that we've got consistent responses to these. So that's just one. Another one would be, and this is in a gold mining operation. Again, I can see some of the metrics that I'm looking at from a monthly, quarterly, and that kind of view, but I can also see what's happening right now with, for example, my crushers. So, and I know that if the crushers are out, I'm going to have a bottleneck downstream. I'll have to throttle back production. That's going to have an impact. I need to intervene. That's kind of as a mine manager, the only thing I need to know today. Otherwise, I'm going to address some of the other challenges that I might have. And again, you could see things like tailings and some of the other key ESG metrics on here. Likewise with greenhouse emissions, there's a lot more pressure on executives to start monitoring that in real time. So how do I make this part of my business model, or my model that I need to look at? So some of it, again, is around quarter to date, year to date, important things, but also what's happening right now. Where are we with some safety incidents that were reported over the last, because I've got a couple of thousand people, need to monitor this and report on this. So these are all key things, and it doesn't always have to be that high fidelity. When you look at this, and again, this is around what's my real-time site KPIs, how good are we doing around the 4 things that I get compensated on or incentivized on as the GM of a mine, and what does it break down into the detail. And again, it's all about these executive recommendations, that when things go, then when we have a challenge, that we know exactly how to respond. When we look at it from a tactical perspective, and the connection between all of this, so there's a user story for the executives here. Likewise, at a tactical level, and I'll start with kind of a user story at a tactical level. So Bruce Dundee, good Australian, his role as a maintenance planner. So he slots into that tactical level. You can see the things that really challenge him is that we're understaffed. If we make the wrong decisions, it's got a really big impact. I want to get promoted. So these are the personal drivers of that person, which we have to take in consideration when we look at digital twins. So based on his background, there are certain user stories. And if we take the crusher example that we saw, there was a problem with that red dot. There was a crusher problem. I want to know what the remaining useful life is. I've got 6 crushers. If 2 of them are out for maintenance at the same time, I've got a really big problem. We have to throttle back production. So as a maintenance planner, I want to know when multiple crushers who need overlapping maintenance, so that I can tell the control room actually to run these things faster. And I want to be able to simulate. So you'll see some of this. So when we get to the example, but this is the important aspects of connecting the different levels. So again, for his role around crushers, there are 12 different things that need to be addressed, or questions that he's got to know. What is the frequency of recent liner changeouts, so that how can we improve the lifespan of liners? Here's the digital twin that represents that. So you could see he wanted to know if there are 2 crushers out at the same time. I need to know, and so we need to predict the liner wear, and there might be some predictive analytics involved in that. In actual fact, there is, in this instance, there's some predictive analytics to predict the wear on the liner, and if 2 of them overlap, we need to know in advance so we can tell the control room to do something. So again, this is giving them recommendations on how to do that. Some of them are overlapping, some of them are doing other things. And for each crusher, you can then see what is remaining, the predicted end of life, 6 days. So if I go into that crusher, and this is all driving lower cost as a value lever. Getting into that crusher, here's the actual crusher. I can see how it's running. I can see all the work orders and everything associated. This is what I need from a planning perspective, so that I can do a next level, tell the operations how to operate this. So the interesting thing is I can also see how this compares to the previous liners that we've had in this same crusher. So that's all important information from a decision support perspective. And again, this is all driving towards that lowering the cost. One of the other areas, that will give you a health of how my operational planning work, not my maintenance planning, but my operational planning is. Quite often, if you've got multiple control rooms and we look at the percentage time in normal PTIN, how that looks, and can I compare across multiple control rooms and see how we are doing, so that we know again from a planning perspective and intervention perspective. So this is going down into a specific control room, looking at the alarms and percentage of time that things are running autonomously versus we have to have manual intervention. Again, that gives us an understanding of the health and how I can plan around that, what I need to do, and which areas are better than others in terms of the performance of an organization. So that gives you kind of an overview of the control room side of things. And then if I drill down again on a specific area inside that, how good are we again at certain of these. So from a planning perspective, understanding which control loops and things are giving us the most issues, so we can plan those. So that's kind of the view, the role, and I can do this across all my different control rooms on exactly the same model. So my digital twin is the model. I then instantiate it for the different control rooms. At the operational level, and again, just going back to the biggest challenge that we start seeing here is how do we connect all of this data? This is where there's quite often a lot of data, complex connections, multiple systems, cleaning up the data, wrangling, doing all of that. And that it's a key almost characteristic is the data that goes to the top quite often needs to go through these processes in order to clean that up so that I can drive the decisions that I'm making right now. So this is looking at my operations view, process optimization. I'm looking at the different circuits here on the crushing side, for example. Right now, what's happening on my plant right now, and where are the potential bottlenecks, or where do we need to intervene from that perspective. And again, just a similar view to that, but focusing on what's happening right now and what can we do to address some of those. Again, all recommendations, or you can call them alerts, it could be recommendations, but that's how we drive it. Again, at an operational level, I need to know which pumps are giving me issues right now. What's happening on my plant. If there's nothing wrong with this, then no dot. If there's something based, and this could be every second, every millisecond, even that this analytic that the digital twin needs to analyze based on an engineering model. It could be that simulation model or machine learning or just a rule. And then based on that, create recommendations for me so that I can go into that piece of equipment, look at it, and analyze it further in terms of what I need to do right now, potentially from a maintenance perspective. So those are the kind of three levels. And just to recap from a summary perspective, it is important to strategically align your digital twins with those value levers and establish that golden thread. So also make sure that it drives what the business outcomes are, and set the KPIs at each level and connect them through a diagram, as I showed earlier, that you make sure that you've got that each of those threads have their KPIs and how it will be measured and how it actually delivers value. So how do I connect all this data and drive the better decisions from the top? So that is how we see the strategy pyramid. When we present this, it gives organizations kind of a clear way of thinking about how do we not just have all these loose standing digital twins that emerge almost like spreadsheets in a business, but how do we make sure that we've got a strategy to connect all of this together and drive the business outcomes that we have. Just very briefly, so what is XMPro and how do we build digital twins? We see ourselves as an application composition platform that provides a no-code environment for industrial business technologists, aka engineers and people like that, to create real-time event intelligence apps, composable digital twins, and industrial IoT analytic solutions. And our focus is how can we help you with business capabilities to be able to create safer, greener, and more responsible industrial operations, do it faster and with higher efficiencies that make it worthwhile for everyone, that drives value levers for everyone in the ecosystem. Quite often asked, how do we fit into this whole industrial ecosystem? And there are a number of players. We see ourselves as that composition platform, bringing things together, connecting them up, composing digital twins to be able to drive outcomes from this. And then how do we do this? Well, we handle the data integration at that bottom level, being able to aggregate it up. We provide the user front end, so to enable that decision support, and also how do we set up that recommendation structure and help let our digital twins become our trusted advisor with recommended actions when we have certain things at all levels of the organization. So that's me. If you want to get hold of me, there's my email address. And what I'll do is open it up for questions to see if there are any questions that people may have. So, so there's one from Antonio. I'm just going to break this out so that I can read it better. Apologies. Excellent. So if anyone's got any questions, just post them into the chat there. We'll go over questions for a while and then we'll wrap it up. So the question is, given the supply chain challenges companies are facing today, is it possible to build an operational digital twin of the end-to-end supply chain? Antonio, yes. In actual fact, it's one of the areas that we see almost at that composite level, one of the biggest growth areas, especially if you've got multiple nodes. So we've, as XMPro, we've been involved with quite a large scale digital twin of a supply chain for a industrial manufacturer who support, I think, I have to check, it's either 120,000 SKUs across including end customers. I think there are almost 1 million nodes in the supply chain. And it's all about short-term inventory planning, which is the biggest challenge that they have in terms of operating across a large geographic region. In Europe, for example, this is also running in different areas, but if they take Europe as a specific example, creating a digital twin, and it's all about, in the end, the operational, how do we make decisions right now in terms of where to make certain products in a certain facility. They've got a lot of distributed facilities, almost micro factories across a large area of Europe, and making decisions around where certain orders are made, fulfilled. How do we change that? That continuous MRP is driven by the supply chain, and having that as a model-driven based approach is the only way that you can manage that at scale. And again, one of the biggest challenges that they've had is a manager in a certain region at a certain manufacturer would make a certain decision on the, let me rephrase that slightly. Based on the same data, they would get different outcomes in different regions by different people on the decision to be made around, do we make it here? Do we send it across to someone else? Do we change out a product? Do we offer a customer something else? That kind of thing. Using this recommendation, getting the digital twin to provide that consistency, has had a significant impact for them. And in terms of the scale, this is the only way they could scale that out. And the benefits of what we're seeing right now with supply chains, being able to run that optimization logic every 15 minutes so that the digital twin can come up with new suggestions has proved invaluable from that perspective. And then there's a follow-up. So in these cases, thanks, Antonio. Follow-up question: do these cases install sensors on the supplier facilities? Yes. So what's interesting is there's actually a mix. So on their larger customers, they actually have sensors on, let's call them tanks, just for lack of a better. I don't want to go into exactly what the products are that they are selling, but let's say there are facilities or like tanks in at the end customer organizations. Let me explain it like this. They actually supply industrial gases. So it's all about filling cylinders and doing all of that. And for some critical infrastructure like hospitals and others like that, they would have sensors installed at the customer facility. So that would give them some real-time intelligence. The other part of the intelligence are orders that are in the system that the customers are placing, like I need these replenished or whatever. But they are driving for large critical infrastructure customers that they actually have direct insight and connectivity into those facilities and know what the levels are so that they can supply them better. And that's all in the supply chain. There's a question from Jan on, do you have any experience of applying this in healthcare, in personal care, also in personalization of care? One of the things I didn't mention on here is that before that diagram from Gartner with the discrete IoT organization, there's actually a digital twin of a person in there. I didn't include it in here because the focus was a little bit more around some of the industrial examples. But digital twin of a person, which and a lot of the use cases are around personal healthcare. The biggest challenge with that right now is, yes, we can do this. The privacy challenges right now is still being worked through. There's interesting use cases where the same analogy applies. So you have certain value drivers, and those value drivers might come from institutions like governments, local governments, things like that, in terms of what they want to drive from outcomes or delivering better service, how that needs to go into planning, and how that then gets executed. The challenge with healthcare specifically is at the moment is there's still a lot of concern from a privacy. So if there's a digital twin of me, where is it going to end up? Who's going to have access? But in terms of the use cases and the application, it is exactly the same process and model. Area where we are seeing some of the personalized or the digital twin of the person being used are in CRM and retail, and it's actually really interesting to see what's happening in the retail space around creating digital twins of, or taking the end consumer digital twin and overlaying that with infrastructure and different. So looking at a shopping mall, how people move, where the feet are, and how can we sell more retail space to larger retailers by showing them what some of the behavior and characteristic of people underneath that is. So those are some of the value drivers are, we want to sell, we want to charge premium for certain areas in our shopping malls. And then how does that relate down all the way to the operational side, where we collect data but also give people things back. I'm just mindful of time, but I'll quickly answer. There's another question. Can you simulate a condition of a digital twin instance with corresponding? So yes. So the question is, can you simulate a condition of a digital twin instance while corresponding physical entity has never experienced such conditions? It's one of the capabilities that we refer to as synthetic data. So how can you create synthetic data that you could potentially use? So it could be modeled based on existing data plus some exceptions that you want to introduce to that. So there's a whole area around synthetic data, and yes, it is one of the capabilities which we'll touch on in another webinar of that you could potentially build into a digital twin. Absolutely. So thank you for that question, Taisuke. And then last question, OPC. OPC UA integration. Yes, we've got standard connectors for OPC. In actual fact, we work pretty closely with the Microsoft team, who's out of Germany, who's very involved, Eric Barnstead and the team there. On the OPC side of things, yes, we have got an OPC connector, like we have MQTT connector, like we have OSI Soft or ADX or Azure Data Explorer. So that's one of the things from an integration point of view, is we've got a large library of integrations at that lower operational level. But yeah, and so yes, for OT factories, OPC, and we see that as a and say Dieter, I see that you know Eric, so say hi to him when you next see him. Excellent. Thank you very much. Really appreciate your time. Great questions. And looking forward to seeing you on one of our next future ones. Thank you.